Okay, hello students and welcome to our lesson on midpoint and length of line segments. So what we want to do is just to calculate the length of a line segment on a Cartesian plane. So the midpoint of a line segment joining 2 points is halfway between 2 points. Now one way to find the coordinates of the midpoint is to calculate the average of the x coordinates and the average of the y coordinates for the two endpoints. The distance between 2 points is the length of the line segment joining the two points. Now, for a line segment containing 2 points, x1, y1 and x2, y2, the coordinates of the midpoint are just the average of the x coordinates, so x1 plus x2 over 2, and y1 and y2 over 2. Now, the length of the line segment is what the square root of the x2 take x1 squared and plus the y2 take y1 squared. And we'll have a look at that in a little bit more detail soon. So to find the coordinates of the midpoint of the line segment joining -1, 4 and 7, 9, just remember what we have here. So we've got an x1, we've got a y1, x2 and a y2, always helpful to label. So all we need to do now is to calculate the average of the x values. So to calculate the average of the x values, it's just x2 plus x1 over 2. So that's just going to be, what's x2 is going to be 7 plus -1. Well, 7 plus -1 is like saying 7 take 1, which is 6. So that's going to be 6. Is that correct? And 6 divided by 2 is 3. And that's what I'm doing wrong there. Let's have a look over here. Now we've got the y values. So it's just y2 plus y1 over 2. And so it's 9 plus 4, which is 13. 13 divided by 2. Well, 12 divided by 2 is 6. So that's going to be 6.5. So the coordinates of the midpoint are 3, 6.5. Let's have a look at a random example over here. So what I've done is drawn a line segment on a Cartesian plane. And let's have a look at calculating things like the midpoint and the length of the line. So let's label our coordinates. So we've got at this set of coordinates here, this is our x1, y1. So x1, y1. That means this is x2, y2. So let's find our first point. So it's 1, 8, and then it's 7, 1. And let's just find the midpoint first of all, and then we might find the length of the line. And we can do this a couple of different ways, but we'll do it this way first of all. Actually, we'll just do it this way. So the average of the x values, so we've got our first one, which is 1, and then 1 plus 7 over 2. Well, 1 plus 7 is 8 over 2 equals 4. And then our next one is our y coordinates, 8 plus 1 plus 1 over 2. Be nice. That's 4.5. So our midpoint equals what? 4, 4.5. If I were to do this on the graph, x value of 4, y value of 4.5, and then I would just see where they hit the line. So that is our midpoint. Now to find the length of the line, what you should recognise is that we've got a triangle here. And this looks like the hypotenuse of a triangle. So we can just think about Pythagoras' theorem, and then what's that? That's a squared plus b squared. The square of the hypotenuse equals the square of the sum of the sides. But let's have a look. This is just written in a Cartesian plane format then. So we're just going to have to find the length of side A and the length of side B. So we're going to just play around with this formula a little bit. So the hypotenuse in this case equals the sum of A squared plus the sum of B squared. Now let's say this is side A and this is side B. We're just going to have to find the rise and the run, aren't we? So let's just turn that thickness down a notch and do this. H equals, now what do we say? The rise and the run. So let's have a look here. So we've got our coordinates for our x coordinates and our y coordinates. So 7 take 1, and so that's our 7 and let's take our 1, so that's just the run. And let's look here, we're going from 1 up to 8 in this case, so it's 8 take 1. So let's just do a little bit of solving. 7 take 1 is 6 squared. 8, oh, that should be a takeaway. 8 take 1 squared. 8 take 1 is 7 squared. 6 squared is 36. 7 squared is 49. But I think I'll just go straight to my calculator and plug this in here. So we want the square root of 6 squared, which is 36, plus 7 squared, which is 49. And that's 9.21. Now I suppose I should just put that whole equation into the calculator to show that's the same and show you how to do it. So we've got our square root symbol, then it's 7 take 1, that would be nice, squared, plus, open brackets, 8 take 1 squared, and there you go, 9.21. Finding the length of the side of the line segment, well, we just did that. For the line segment shown, we could do the midpoint. So that's just like I showed you, find the coordinates and take the average of them and then find the gradient. Oh well, remember gradient is just rise over run. I want to find nice points where they cross the line. Well, that's going to be a nice point. So none of these are crossing until we get to there. So there to there. So remember, rise over run. Now we're crossing over the axes here, so we're going to be plussing them together, aren't we, for the going across, which is the run. So rise over run. So we've gone from 1 up to 5. So 5 take 1 is 4. And then we've gone from -3 up to +4, so that's 4 over 7 for our gradient, which is 4/7. And it's easy enough just to keep it as a fraction because the decimal would be a recurring one. I'd like you to work on the mastery exercises now, please, students.